For question 16, we're asked to do a proof. And we have been in this situation before. Let's start with the more difficult side. So the more difficult side is the side with more stuff. And I'm going to start with the left-hand side. I'm going to copy it over, and then I'm going to manipulate the heck out of it until it looks like the right-hand side. So the format is what we have been used to all year. I'm going to start with, let's just write down the left-hand side. So I have n choose r plus n choose r minus 1. And I am just going to use the definition of combination. So the formula is this is n factorial over r factorial n minus r factorial plus, for this second expression, this one right here, again, I'm going to just use the formula. So that is n factorial over r minus 1 factorial times n minus parentheses r minus 1 factorial. Let me move this over a teeny bit here. Right. So factorial right over here. Now, my task is to take what I have on this side and manipulate it. So rewrite it, rewrite it, rewrite it. So I'm going to have something that looks like this. I'm going to rewrite equals, equals, and at a certain point, I'm going to keep on simplifying it, keep on simplifying it. So at the very end, I'm going to end up with equals. Right, at the very end, I'm going to end up with equals n plus 1 over r. Now, I am going to work backwards one step because I know that this is going to look like n plus 1 factorial over r factorial, and then I'm going to have n plus 1 minus r factorial. So this right over here, that's what we're aiming for. So let's go back up and see what we can do with this. Now, what I notice is that I have a few things here that are kind of lucky. I have an r factorial right over here, and I have r minus 1 factorial. And I know that I need to combine these two fractions into a single fraction. So r and r minus 1, let's see, r is the bigger number. I'm going to rewrite this and just play around with this a little bit. So my first fraction is still n factorial, but I'm going to write the bottom as r times r minus 1 factorial times n minus r factorial. And while I'm at it, I'm going to clean up the right-hand fraction. So this is n factorial r minus 1 factorial. And then I'm going to rewrite this. This is n minus r plus 1 factorial. And then I'm going to notice something again. I'm going to notice that this number right here is 1 bigger than this. So I'm going to rewrite this part. So again, I have n factorial, I have r times r minus 1 factorial, n minus r factorial, plus, and now here I'm going to have, let me move this over a little bit. So right over here I have n factorial, I have r minus 1 factorial, and then I'm going to write this, move it over a little bit more. Oops. I want the whole thing to come along here. So this is going to be, let's see, I'm going to have n minus r plus 1 times n minus r factorial. I know that these are consecutive integers. Well, now when I look for a least common denominator, well, let's see. I know I need to have an r minus 1 factorial. Got that. But this one has an r, so I need an r on the right-hand side. So I'm going to multiply top and bottom by r. Right, so r over r there. And let's see. The one on the left, I need an n minus r plus 1. So I'm going to multiply the top and the bottom by n minus r plus 1. So I'm going to make this a little bit neater. So let me just pull this whole thing up here. Pull this whole thing up. Okay. And I need a little more room, so I'm going to erase this thing. Get this out of here for now. Okay. So once again, I need an n minus r plus 1 on the left-hand side. So I'm going to have n factorial. I'm going to multiply the top by n minus r plus 1. And then in my denominator, I'm going to have r times r minus 1 factorial times n minus r plus 1 times n minus r factorial plus, and for my second fraction, it's just the r's that I need to multiply. So I'm going to have r times n factorial, and then in the denominator r times r minus 1 factorial, n minus r plus 1, times n minus r factorial. Okay, it's kind of messy, so let me squish this and see where we are. Okay, so I'm going to fix it up a little bit. Clean it up here. Get rid of this. Okay, at least I have the same denominators. So I'm going to write this with a single denominator. So my denominator is going to be, let's see, I have an r and r minus 1 factorial. So I'm just going to write that as r factorial. I have n minus r plus 1 times n minus r factorial, and I'm going to write that as n minus r plus 1 factorial. In my numerators, I have n factorial times n minus r plus 1 plus r times n factorial. So in the numerator, what I would like to do is perhaps factor out this n factorial. Factor out this n factorial. So that's going to give me n factorial, and I will have n minus r plus 1 plus r in the denominator. In the denominator, I have r factorial. And I'm going to rearrange the bottom because I remember what I was trying to do. I'm going to write that as n plus 1 minus r factorial. Let's just tidy this up a little bit. So in my numerator, I'm going to write this as n factorial, and that's going to give me n plus 1. In the denominator, I have r factorial, and then I have n plus 1. I'm going to put that in parentheses, minus r factorial. And if I have n factorial times n plus 1, well, n plus 1 and n are consecutive numbers. So I could consolidate that a little bit. And I'm going to write then the top just as n plus 1 factorial times r factorial. And then I have n plus 1 minus r factorial, which, lo and behold, I can rewrite in combination notation. So this is nothing other than n plus 1, choose r, and we are done with the proof. So let's see if we can stand back and look at that. Woo, that is a long proof. But there we are.